For more complicated fractions, it is easier to use long division to convert to a decimal first, then convert the decimal to a percent. Do that by moving the decimal 2 places to the right. For example, to convert 2/11ths to a percent, I would use long division to divide 11 into 2, and you see we end up with 0.181818 with the 18 repeating forever. So 2/11ths is the same thing as 0.181818 with the 18 repeating. Move the decimal 2 places to the right, and we end up with 18.18 repeating percent. All right, let's express each fraction as a percent. So 3/11ths would be, figure out how many times does 11 go into 3. Well, 11 doesn't go into 3, but it goes into 30 twice with 8 remainder. 11 goes into 87 times with 3 remainder, and now we're going to be repeating. So 27, 27, and repeating. Move the decimal 2 places to the right, and we'll have 27, and then 27 repeating percent. For the next one, we want to take 5 and divide it by 3. So 3 goes into 5 once, 2 remainder, and then 3 goes into 26 times, 2 remainder, and then 6, 6, and so on. So it looks like this would be, if I move the decimal 2 places to the right, I would have 166 and then 6 repeating percent. All right, so here's a variety. Let's try to express these percents as fractions in lowest terms. 60% is 60 over 100. Divide by 10, that's 6 over 10. Divide by 2, that's 3 over 5. 125% is 125 over 100, which if I divide by 5, that becomes 5 over 4. And which is an acceptable answer, but you can also write it as 1 1/4. And for part C, maybe a little bit simpler to convert to improper fraction first. 33 times, or 66 times 3 is 180, 198, plus 2 is 200. So this is 200 over 3%. And so this would be 200 over 3 divided by 100. So 200 divided by 100 is 2, and we end up with 2/3. Order the numbers from least to greatest. So in this case, I would convert them all to be the same format. Let's go with, I guess percent works. So we already have 2 of these as percents. This one's 13.55%. This one's 13.6%, 60%. If I multiply top and bottom by 4, that would be by 4. I have 120, that'd be 132 over 1,000. So that'd be 13.2%. And then this one here is 13.555 repeating percent. So the least is that 33 over 250. This is the least right there, 13.2%. And then 13.55 would be next. 5555 repeating is the next, and the largest is the 13.6. So from least to greatest, 33 over 250 is the smallest. Next is the 13.55%. Next was the 13.5 repeating percent. And the largest was the 0.136. All right, so let's estimate the percent of the square that's shaded in this diagram. And well, let's count the total number of squares. So on these sides, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 100 squares overall. And figure out how many of them are shaded. There's a couple ways you can approach this, but we want to estimate. So just estimate how many squares are shaded. So there's 2, 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 19, 20. These two make up 21. These two make up 22. These two make up 23. These two make up 24. These two 25. And then the bottom half is the same as the top half. So that comes out to be 50 squares shaded. So that becomes basically 50%. And this one's a little tougher. But so as a rough estimate, this is still over 100. And we want to know how many of these squares are shaded, or approximately how many. So let's count. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And these two are mostly 15, 16. So there's 16 that's mostly shaded. And then it's here. This one and this one are basically like 2 halves. Say this one and this one. 15, 18. So I should keep track. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we're at 18 right now. And how many more can we make? Let's say that these 3 make up 1. And let's say that this one and this one makes up 1. And these 3, the last remaining, make up about 2. So as a rough guess, I'm going to say about 22. So about 22% is shaded.